In Lab 10, working with text, we will learn how to redirect and pipe standard input, output, and error channels. Also use regular expressions to filter the output of commands or file content, and view large files or command output with programs for paging and viewing selected portions. In 10.2, we are introduced to command line pipes and redirection. We have three ways of doing this. We have stderr, which is standard error. We have stdout, which is standard output. And we also have stdin, which is standard input. Standard error is for displaying error messages. Standard output is for displaying output. And standard input is when the user types something and it's written as input. In 10.2.1, we are introduced to the redirection symbol, which is this greater than or directional character, and we use this with the echo command to redirect the output from the normal output to the standard out to a terminal file. The cat command can be used to display file contents, and we're going to use it in this example as well. So first we are going to clear the console, and we're going to type out echo hello world. And this should just print it to the console. If we press enter, we can see that it went to the console. Now, if we want to move it in somewhere, what we can do is have our echo command. We are going to have our hello world. So this is normal, but we're going to have an arrow which points it basically to where we're storing it. And this is going to be stored into the file my message. Once we press enter, we can see that nothing happened in our console, and that is because it went into my message. If we want to see my message, what we can do is do cat my message. Pressing enter, we can see that hello world is in my message. In 10.2.2, we're just going more into the arrow keys and basically what it does. And if we just have one arrow key, like we had previously, where we did echo hello world key message, we had it go into message, and if we typed out cat my message, we could see that in here we have our hello world. If we were to replace this, like let's say we would do echo, but instead of hello world, we would just do hello and press enter, and then do cat my message, we can see that we actually overwrote our hello world. And this is because having one arrow only means that we're only going to have one line. If we want to append to this, what we need to do is have two of these arrows. We'll have echo, and we have hello here. So the next line we should just have world. Now we'll have hello world. We need two arrows, and we're moving this into my message. If we do cat my message, we can see that by pressing enter, we have hello and world. We only need two arrows to keep appending. One is to overwrite, two is to append. So if we do this again, we do echo and the world, two arrows and message, but we're going to change our world into something else. We'll change it into greetings like the example shows us, and this should append it underneath world. If we press enter, we will do cat my message, press enter again, and we can see that we have hello, world, and greetings. Now if we wanted to overwrite this, we can just write first and just a single arrow my message, and by doing cat my message, we can see that we have overwritten everything in our file, basically starting over. In 10.2.3, it also gives us an example of this appending. In 10.2.4, we're introduced to the find command. The find command was not in the reading for this section, but it is pretty cool. So we can use it in our console by using find, and then our directory, which we will use a line like this, the about symbol, to represent our home directory. We will have a dash name, and then what we are looking for. What we're looking for is going to be in parentheses, and we will have ** bash. By doing this, we can see that we have these two things that come up. And I think the ** in this instance is basically saying that 0 or more characters can be on either side of the bash. Now we're going to use the find command again, except for a different address. We'll use find /etc, so this is just a directory. We're not going to be in our home directory anymore, so we're doing /etc. We'll have /name and then hosts. And we can't go in here, even though I spelled host wrong. We can't go in here because my permission is denied, and I guess I just don't have access, and it gives us a description for that right here. We do not have permission to access certain files or directory. This is because as a regular user we don't have the right to look inside some directories, and this gives us error messages. And down here it tells us the find command is beyond the scope of this course, so me trying to explain it up here was probably incorrect, and it is just used to demonstrate the difference between stdout and stderr. To redirect stderr messages to a file, we need to use the following command. Again, the find is not really important to this chapter. We are just getting an error, so we want to get an error specifically here, and we want to move this error to a text file. So we are just going to go up one by using the up arrow key, and we'll have this, and recall this gives us an error. I'm going to spell this correctly though this time, and this will still give us the same error, but we want to move this into a file. So after we have this, we need toError, and the to means error message. A one arrow indicates a stdout. So stdout is one arrow, and then stderr is two, then the arrow. And now we want to make a text file for this, or we want the address of a text file for this. So we're going to say error.text, and this is where it's going to store it into. If we press enter, we can see that this is all the output we get. And if we cat our file name, which is error.text, and press enter, we can see that we have our error written right here. It's a permission denied error. We just stored it in this text file so that we can see it for later. Down here it tells us where this can be useful. It tells us that the previous example demonstrates why knowing redirection is important, and if you want to ignore the errors that the find command displays, you can redirect those messages into a file and look at them later, making it easier to focus on the rest of the output of the command. If we had output and we had an error, we could redirect these into two separate files. This is good in case we want to separate our output from our error. So we can clear our console for now, and we will just focus on the example that we're given. We are going to use our find command just like this going up. We have our find command here, and again, outside of the scope of this class, so we're just using this to create an error. If we press enter, we can see that we have this error right here. Now we want to store output, which is this part right here, and we also want to store the error, which is this right here, into two separate things. However, we can do this on the same line. So we are going to get this, again this will give us our error, and the first thing that's going to print out is this part right here. So what we can do is write where it's going to first. We will have one arrow. We don't need to write out the one. It just is an arrow right here. So the one is left out of it, and we're just having an arrow. And then we have std.out, and this is going to be our file name. std.out is a file name. To make it more clear, we can do std.out, or we can do stdout.text, and then we can do a toError, which means that the error, which is this is the error part, is going into std.err.text. The only thing I'm changing here is the file name. So this is our output and error. We store the first output in our stdout.text, and then our error in stderr.text. If we press enter, nothing gets outputted to the console. That is good. So we can start using cat and looking at these. We'll use cat and stdout.text first. Pressing enter, we can see that we got the text. If we do cat stderr.text and press enter, we can see that we have the error, and these are stored in separate files now. In 10.2.7, we now cover on how to redirect both the output and the error, like we did this, except instead of putting them in two different files, we're going to put them in the same file. We will go up using our arrow key to get the actual error. If we press enter here, we can see that this is what we get. We get a little bit of output and a error right here. Now we want to store this in a file. So we have this right here. This is what we have to get our output and error, and now we just need to move it to a file. So since we're moving it in the same file, we will just have an arrow and then the file name, find.out. That's what they want to call it. But we know that the error part is represented with a toError. So we'll have 2 arrow, and then we have an and L. I made an error right here. This should not be L, this should actually be 1. So it's representing, and it makes sense too, because this single arrow right here represents the output, and then this 2 arrow represents the error, and then we have the and 1, and this will represent the output combined with our error. That's why they're both together with an and. If we press enter here, now we can see that we've done it correct because no error has popped up in our console. In fact, we could probably store this error in another text file. So then we'll do cat find.out, because find.out is our file name. Press enter here, and we can see that these are both stored into this file. And this is the actual description of what the 2 arrow and 1 does, and it sends the std error channel 2 to the same place where stdout channel 1 is going. In 10.2.8, we are introduced to the tr command. The tr command translates characters, and it can only accept data from std.in. So we will have tr a through z, and then we have a through z. And what this basically means is it's translate the lowercase letters from a to z to the uppercase letters a through z. If we press enter, we can see that we just have a cursor blinking right here, and this is where we can input something. So if we write "this is interesting" and press enter, we can see that this all goes to capitals. Next is how do I stop this, and even if we have capitals in here, like if this is capital, it would still push it to be capital. To stop this, we would use Control D at the same time. We would press Control and then D to exit this. In 10.2.8, we can get this output and actually send it to a file. To do this, we are just going to have our tr translate, and if we want this to go from capital to lowercase, we would do a through z first, but these are capitals, and then a through z lowercase. And we would have a direction, our arrow pointing to a new file, which would be my file. If we press enter, now we are allowed to type. If we want to type the example, we would do wow I see now, where I see now is in all capitals. If we press enter, we can type some more. We would do this works, all caps, press enter again, and then just Control D to exit. We are now out of here, and we can look at the my file by doing a cat my file. Pressing enter, we can see that this is all pushed to lowercase. Lastly, we can also execute commands using the tr and redirect our stdin file. So if we have our my file right here, we can actually read it and then convert it. So if we want to convert this to uppercase now, what we could do is tr a through z, because it's lowercase, my file is now lowercase, or at least the contents in here are lowercase, and then we have an uppercase a through z, and then from here we are just going to have our direction. We want our file to go into our translate, and then our file name, which is my file. If we press enter, we will see that we have output wow I see now, this works. In 10.2.11, we are introduced to the more command, and this is used to display one page of data at a time. We know that the ls command sends a list of whatever directory that we're in, and the -l makes it long, so it gives us a lot of data. If we don't want all of this displayed at one time, we can use the more command to separate it into pages. If we did ls-l/etc, which is the directory, and press enter, we can see that we have all of this, and we would need to scroll through a lot of data just to read through all of this. So instead of doing this, what we can do is our ls-l/etc, and then pipe it to more. So we are sending this command to more, and by doing this, we will have one page at a time. So we can see that this is all just one page. Our command was right here, and we can view all of this at one time. To view the next page, we're actually told what to do down here. We can press the spacebar to continue, and we will go through more pages, and we can continue down the list, and once we get to the end, it'll break us out into a new command line. If we were still in here though, and we wanted to escape the listing before we reach the end, we would just use a Control C, and this breaks us out into a new command line. We were also told about the cut command down here and its uses with the pipe character. In 10.2.12, we are going more in depth with the cut command, and we are going to call the cut command to extract all of the usernames from a database called /etc/password. In this example, we just do a cut -d and then a colon, and this is for delimiter, I think it's called. Basically, this is what it's going to be looking for when looking at the different tokens. And then we have -f, which is looking at the file, 1, and then /etc/password. And pressing enter, we get the same output that they do here. Pressing next, we can see that we have a continuation of this example, and the output of the previous example was unordered and scrolled off the screen. We are going to take the output from the cut command and send it to the sort command to provide order for it. If we look at all of these, we can see that they are all out of order. So what we're going to do is we are going to take this, so use the same exact command, however we are going to pipe or pass it into sort. If we press enter here, we can see that they are all now in alphabetical order. Even though it's in alphabetical order, it's still long. We can't really view it all in one page. So what we can do is scroll up again, and we have our command which gets all of our passwords, it cuts it. We have our sort command, but if we just want to view it one page at a time, we can pipe this to our more command and press enter, and we can see that we can easily view this on one page, and press spacebar to view the next page. In 10.3, viewing large text files, we are told about the less command and how it is a more advanced version of the more command. Both of these are fine, they're both more advanced than just using the cat command, but in this chapter we will be introduced to other ways we can filter the contents of the file or output. One of these ways is using the head and tail commands. In 10.3.1, we are shown the cat command being used with /etc/password to display all of this information on the screen. In 10.3.2, we are shown how the more command can make this easier to view by separating it in pages. If we type more and then our directory etc/password and press enter, we can see that we have a certain percentage, and if we press the spacebar, we have gone through the entire thing. And I think the percentage is the amount of viewing that we can see, or we have seen so far. And it tells us that exact statement right here. While using the more command, we can press the H key. So I will go back and do more /etc/password, press enter, and then I'll press H, and then we can see all of these different things that we can do. These are all of the different movement commands. 10.3.4 is about the spacebar and how we can go through the entire document by using it. We can also search for a pattern with both more or less commands by using the / followed by the pattern defined. So if we exit out of this help menu by using Q, we are going to be back in our command line. However, if we wanted to still be in our document, I'll do more /etc/password, and we were in our help menu but just wanted to go back to the document, we would just press B, and now we are back here. If we want to look something, if we want to look for something, we do a / and then we follow this up with a pattern we want to find. If the pattern is not in here, it'll report that it's not able to be found. So if we were to do like /running and press enter, it'll say pattern not found. We can just do a / again to look for something, and we will look for bash. If we press enter, we can see that it gives us this output right here. If we wanted to search for something else, we'll do this again, and we did /login and press enter, we would then get this information. In 10.3.5, we are shown the less command and also the searching option, and then ends to move back and forth with our search, and then a Q to quit. So we are going to try this, first clearing the console and then writing out less, and then our directory, which is /etc/password, and then pressing enter. Now we have all of this information in here. We can do a space, we go to end. If we press B, we go back to the first page. If we want to search for something, we'll do a /. It says bin, so we will do bin like this, and then this is definitely a whole lot better than with the more command, and we can see all the instances of bin are highlighted. If we press N, we can go through every single time that it is used. If we go past this, we get these lines and then N. If we want to go back, we would do shift and N, and then we would go back through these. To quit, we would just press Q. If we just wanted to display the head of the command, we could type in head and then /etc/password, and we would display the first 10 lines of our command. If we want to see the last 10 lines of our document, we would do tail, so tail /etc/password, and this shows us the last 10 lines of our document. We can also specify how many lines that we want to see, so we can clear this, and then do our head etc/password. This gives us the first 10 lines, but if we wanted to see only the first 2 lines, we would do head, and then this takes an option, so we can have the number -2 and then /etc/password. This gives us the first 2 lines. We can also use the tail command with piping. So if we have the ls/etc, we are going to get the listed contents of the /etc directory. We'll demonstrate that here with a /etc, and we get all of this stuff. This is a lot of stuff here. If we only wanted to view the last 5 things, what we can do is do a /etc, which would get our contents, and then pipe this into a tail where we have a -5, and in our tail -5, if we press enter, we are just going to get the last 5 lines inside of etc, which are these. Another way to use the head command is to use the -n -number option, where number is the number of lines counted from the bottom of the output to exclude. We have our number, which is here. This is basically the amount of number lines. If we contain 27 lines, and then we have this -20 after it, we're just going to be printing lines 1 through 7. So in our code, we have our head, so we know that we start at the beginning. And then we have a -n, which is the total number of lines. In this example, it's 27. We'll have a minus however many that we want to subtract off of it. We'll say 20 here, and then we have our directory, which is /etc/password. And since we have 27 lines in here, and we're subtracting 20 off of it, we should just print out the first 7 lines. Pressing enter, we can see that we get 7 lines right here. In 10.4, we're introduced to searching text using regular expressions. We have the grep family of commands that we're going to use. The grep command uses basic regular expressions, special characters like wildcards that match patterns in data. The grep command returns the entire line containing the pattern that it matches. We also have the -e option to the grep command, which can be used to perform searches with extended regular expressions, essentially more powerful than simple regular expressions. If we use the fgrep command, we can match literal characters and ignoring the special meaning of regular expression characters. In 10.4.1, we have the grep command in its simplest form. We are going to change the directory to etc, and then it wants us to do a grep sshd password. The sshd is the string that it's looking for. So the syntax for this is grep, and then we will have our string to specify, but if we wanted to, we could also have options in front of this. So this is optional. The options are optional. We don't have to include them. We have grep, the optional availability to have options in here, the string to specify, and then we also can have the directory if we're not in it already. And then we need our directory after this. So we have grep, options, string to specify, and then directory. This is just the syntax. If I press enter, we are going to get an error because this is just a comment basically. So for this example, we're going to have grep, no options. We're just going to have the string that we want to specify, which is sshd, and then our directory, which is password. Pressing enter here, we get this output. In 10.4.2, we are shown this again with the grep command, no options, our string to specify, which is root, and then our directory, which is password. Pressing enter here, we get root. If we want to limit the output, since we got multiple roots here, we can use regular expressions. We have the caret character, which can be used to match a pattern at the beginning of a line. The syntax for this is going to be grep, and then we have 2 single quotes, and then inside of our single quotes, we're going to have 2 things. We're going to have our string that we want to find, or our string to specify. And then before our string that we want to specify, we're going to have the caret in front of it. So single quote, caret, string that we want to find, and then another single quote. And then we need to have our directory. This is going to give me another error if I press enter again, because this is just syntax for it. We will have grep, our single quotes with a caret out front, and then the string we want to find, which in this example is root. So we'll have root here, and then our directory, which is password. If we press enter, we can see that we only get 1 instance of root, which is this part right here. Again, because if we have a caret, it is an anchor to the beginning. That means this string that we're specifying must be at the beginning. Previously, when we did something like this, we didn't have any single quotes around it. However, if we put single quotes around it, it would give us the same thing. So we will do grep single quotes sshd and then our directory, which is password, and press enter. We can see it gives us the same thing. So single quotes match the pattern anywhere on the line. In the previous example, they use the sync string, so we're just going to clear this and do this so we can be on par with the lab. We can see that we will get the same output as well still. In 10.4.5, we are introduced to the dollar symbol, and if we put this at the end of the line, it ensures that the character is at the end. The syntax for this is going to be grep our single quotes, and then inside of our single quotes, we have the string to specify, and then right after our string to specify, we are going to have this dollar sign. And then after this, we are going to have our directory, and that is how we are going to do this. So we will have grep our single quotes, our string, which is going to be sync, and then our dollar sign. Again, the dollar sign means that this character has to be at the end. So for this example, it should only highlight this when we print it out again. We're going to give it our directory, which is password. Pressing enter, we can see that it only prints out this last one. In 10.4.6, we were introduced to the period character, the dot, to match any single character. So this dot basically represents A through Z. It could be any character, one of any character. So still being in the /etc directory, we are going to have grep. Our new syntax is going to be the single quotes. Inside of our single quotes, we will have our string to specify, and then we need to put our dot somewhere. We can have as many dots as we want, wherever we want. So we can have it in front of our string, which would be on this side. We could have it after our string. We could even have it in the middle of our string. And then we would also just have the directory after our single quotes. So in this example, we have grep, our single quotes, a dot at the beginning, the character Y, and then directory being password. Pressing enter, we can see all of the instances where we have a letter in front of Y, or a character in front of Y, and this happens a lot. If we wanted to limit this even more, we could go back up here and do a dot after this, and we see that we get a little shorter of a list, I think. But if we were to do two characters in front of this like this, we can see that it doesn't highlight any of these first ones because there's only one character in front of it and not two like this dot specifies. In 10.4.7, we are brought back to the pipe character, also known as the alternating operator or OR. We have the grep and the pipe in between these strings, and what this means is that any of these can be included. So we will have grep, our single quotes, and then inside of here all the strings we want to search for. We have sshd, we have our pipe, we have root, and we will have operator. Lastly, we want the directory, which is password, and pressing enter here, we can see that nothing came out. The grep command does not actually include the pipe operator. This is something for egrep. Since this is an extended regular expression, we need to use egrep, not just the regular grep. If we go to 10.4.8, it shows us how to do this. We have our grep -e, and then we have our single quotes. Inside of our single quotes, we're just going to have the same thing. We have sshd, our root, and then the operator. And then lastly, we have our directory, which is password. Pressing enter here, we can see all of the different times that these are used. Again, we have to use the -e after grep to get the extended mode for grep. In 10.4.9, we are introduced to another extended expression for egrep, and instead of using the -e, we are going to have an e in front. This can be a little bit confusing, but this is the command for it. We have egrep, and then we have our single quotes, which is standard, and then our directory. Inside of our single quotes, we want to look for something, and we have a no. So this is what our string has to start out with, and then after this we can have parentheses, and then inside of here we can have any character that we want with it. So in this example we have B or an N, and what this is saying is that it'll search for something with a NOB or an NON, and it'll look for both of these. So we will have knob and non being searched for. If we press enter here, we can see that we have an NOB here, NOB here, NON here, NON here, and NON here. The parentheses limit the scope of the OR operator, and without them, a pattern such as the NOB /n, we meant to match either a NOB or an N. So we need the parentheses in order for this specific command to work. In 10.4.10, we are introduced to ranging. So we can use these brackets like this, and inside of it specify our range. I'm going to clear this, and we are also using a pipe for this example. So we have the head password, which will give us the first 10 lines from our password. We can show this here like this, but we are going to pipe this into our grep command. This is just a normal grep command, nothing special, it's not extended or anything, not egrep. So we will pipe this to grep, and then we will have our single quotes like this. Inside of our single quotes, we will have our braces. Inside of our braces, we need to have our range. For this example, we have a number range, so we'll use 0 through 9 in here. What this is saying is we are looking at the head password. That means the first 10 lines of our password. We are using the pipe operator to pass it to grep, and then we are searching for anything with 0 through 9 in it. Pressing enter, we can see that we have highlighted all numbers from 0 to 9. In 10.4.11, we can see that we can combine these brackets with these braces. And what braces mean is that it specifies the repetition of our pattern. So we will do our code again, but instead of piping, we are just going to write out a grep command. I'll clear this so that we have a fresh workspace, and the regular syntax for this will be grep-e, because this is extended. Not this range part, but this repetition part right here. So we have our -e, and then inner single quotes, we are going to have our range. And this example is from 0 to 9, and then we want our repetition to be 3. That means the numbers has to repeat 3 times in a row. It's not going to repeat any more or any less than this. So after this, we will specify our directory, which is password, and press enter. We can see here that the first 3 are highlighted. Same thing with this one and this one. First 3 are highlighted here, the next 3 are highlighted here, and then the same thing for the rest of these. They're all highlighted 3 at a time, or not at all. And that is the end for Lab 10 working with text.